All right, so real quickly, we're briefly going to look at solving quadratics that have imaginary or complex solutions. We already know an entire plethora of ways to solve quadratics. We haven't seen any that have complex solutions, hence this video. So, how do we express them? You express them the same way you do any um, complex number, namely a plus bi, right? So, for example, x squared plus 16, well, we've seen that one before. That's going to give us x is equal to plus or minus 4i. So that means one of our solutions is positive 4i. The other solution is negative 4i. Okay, so another one. Divide both sides by 4. Uh, we end up with x squared is equal to negative 9. And when we actually solve that, we get x1 is going to be negative 3i, because we're going to take the square root of both sides, and the other solution is going to be positive 3i. Okay, so not anything too new. So now let's look at some more complex examples that aren't just straightforward, getting x by itself. So we're going to do these by completing the square. So x squared minus 6x plus 12. If we go ahead and complete the square, we have x minus 3 all squared minus 9 plus 12, right? And combine these two. That's going to give us x minus 3 all squared. If we combine these two, we're going to get a positive 3, subtract 3, so negative 3 on the other side now. Take the square root of both sides, so x minus 3 is equal to plus or minus I square root of 3. Okay, because we would have, I'm getting too ahead of myself. I want this video to be short, but I guess I shouldn't skip everything, right? So take the square root of both sides. Square root of negative 3, of course, that factors down into I square root of 3, or square root of 3 times I. And that means one of our solutions, so we're going to add 3 to both sides, of course, also, right? So that means we're going to end up with x1 is 3 plus the square root of 3 times I. Again, we need it to be a plus bi. X2 is going to be 3 minus the square root of 3i. Those would be my two solutions there. Okay, and let's look at our ugliest example on here. Actually, this would not be the ugliest example. It would be number 2. So I'm going to do the ugliest example. So obviously, we want to divide everything by negative 2. So x squared plus 3x plus 13 over 2 equals 0 still. Then we complete the square. So x plus 3 over 2, all of that squared minus 9 over 4 plus, and I'm going to go ahead and multiply this 13 over 2 by 2 over 2 to get the common denominator of 4. So that would give me 26 over 4, and then that's equal to 0. That is going to give me 17 over 4. Okay, and of course that's positive now. Subtract 17 over 4 and take the square root. So that's going to give me plus or minus the square root of negative 17 over 2, because the square root of 4 is 2. And then that's set equal to 3 over 2 plus x. I don't know why I put parentheses. Okay, and then we subtract from both sides. So negative 3 over 2 plus, so this is going to be x1, negative 3 over 2 plus, we'll say square root of 17 over 2i. That would be one solution. And then x2, of course, is going to be negative 3 over 2 minus square root of 17 over 2i, and that would be our other solution. Okay, so those are some examples with completing the square. Now let's look at some examples briefly that have to do with the quadratic formula. And in case you forgot, quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, that doesn't look like a c, all of that over 2a. That doesn't look like an a. There. Okay. So we're just going to put the numbers in where they go. So a, b, c. So a is 1, b is -4, c is 13. So that means x is equal to negative b, because it was already negative, right? So -4 is +4, plus or minus the square root of 16 minus 4 times a times c. All of that divided by 2 times a, which is just 2 times 1 in this case, so just times 2. So 4 times 1 is 4. 4 times 13 is 40 plus 12, so -52. So now we've got 4 plus or minus the square root of -52. Ugh. All of that divided by, oh, no, that would not be -52. It'd be 16 minus 52. What am I, stupid? 16 minus 52. Okay, and 16 minus 52 is going to be -36. Okay, so now we've got x equals 4 plus or minus the square root of -36, all of that divided by 2. So we really have, if we split this up, 4 over 2 is 2, plus or minus, we would have 6i, also over 2, right? And of course that can reduce. So we really have 2 plus or minus 3i. So x1 would be 2 plus 3 times I. X2 would be 2 minus 3 times I. Okay, and let's look at one more example with the quadratic formula. I'll use blue. Let's see, what is the ugliest one here? See, and I can't stress enough, completing the square, when it comes to just pure algebra like this, completing the square is a lot easier than doing all of this tedious arithmetic that's involved with the quadratic formula, but sometimes you just don't have a choice. To each his own, I guess, right? Okay, so again, A, B, C, right? And of course, we see B is negative. So that means x equals negative b, so -4 is +4, minus, plus or minus, the square root of 16 again, minus 4 times a times c, all of that over 2 times a. So 4 plus or minus, so 4 times 4 is 16. 16 times 3 is 48. So we have 16 minus 48. Okay, so 16 minus 48, that would be -32. So square root of -32, all of that over 2 times 4, which is 8. Okay, and square root of 32, we can factor that into, so 4 plus or minus, that would be 16 times 2, so 4 times the square root of 2, all over 8. We can reduce, so I can say that this becomes 1/2 plus or minus square root of 2 over 2. Oh, and that's supposed to be a -2. Whoopsie. So -2. Okay, so that means x1 is supposed to be 1/2 plus square root of 2 over 2i, because of that square root of -2 there, that factors into the square root of 2i. And our other solution would be 1/2 plus, whoops, not plus, minus square root of 2 over 2i. Okay, so that does it for this video. So nothing really changes. We're just solving more quadratics. The only thing that's different is how we express our solutions is a little bit particular. It needs to be in the form a plus bi. All right, like always, send me an email or come see me during tutoring. That's the end of this video. Goodbye.